Okay, so we're here at the bottom of page 1 in 7.5. The instructions say to factor completely or state that the polynomial is prime, check factorizations using multiplication. And I apologize, at the previous video, page 1A of 7.5, I just was happily going right on with the example and I forgot to adjust the camera down. So we've actually already talked through this one, but I'll talk through it again so that you can see the writing as we go. So the problem is 2x to the fifth plus 128x squared. We're going to be boringly good. Check for a GCF. In this case, yes, it has a 2x squared in common. 2 can go into 2 and 128, and there's an x squared in both terms. So we pull that out. What that leaves behind is 2x to the fifth divided by 2x squared is x cubed. 128x squared divided by 2x squared just leaves you with the 64. So once we pulled the GCF out, it is one of the factors. So to factor completely, we need to include that in our final answer. So I went ahead and wrote that down at the bottom to remind me, and I wouldn't drop it out of my answer and forget about it. And then I focus on what's left over, and that's when we ask how many terms. In this case, x cubed plus 64 is 2 terms, which means we have 3 choices here. It has to either be a difference of squares, a difference of cubes, or a sum of cubes for it to have a special formula. Even if it feels like it should have a way to factor a sum of squares, there is no factoring for that one, so that one does not work. If it's not one of these 3 matches, then you're done. It's as factored as it will go. It won't go any further. So in this case, it's a plus, x cubed plus 64, so it won't be any of the differences, because differences are subtraction. So our only hope for factoring this further is if it's a sum of cubes. Is it 2 perfect cubes added together? And in fact it is, because x cubed is x times x times x. 64, yes, it's a perfect square, 8 times 8, but it's also a perfect cube, 4 times 4 times 4. And so how do we factor that? Well, the formula that we should be memorizing, and how do you memorize something? Write it, say it, see it, and hear it every time you use it. So a cubed plus b cubed equals, you make the small 2-term factor, and then there's a bigger 3-term factor. You put a and b, then you put a squared and b squared, then you multiply them together, ab, and that goes in the middle. And then the signs follow this pattern, soap. Kind of like cube of soap, bar of soap, you get the idea. When you have cubes, this is the pattern that it follows, soap. Soap is S for same, so it's a plus here, so we match it, make it plus. O is for opposite. It's the opposite of what we see. It started as a plus, so we put a minus. And then AP is always plus. So that means you always put a positive here no matter what your starting sign is. So same, opposite, always plus. Now in this case, we've got x cubed plus 64, so we can follow our pattern here. Our a value is x, and our b value is 4, so we put x and 4. Then we square those, x squared and 4 squared is 16. Then we multiply them, 4 times x, put it in the middle. And then we follow our pattern of signs. This is positive, so we go same, positive, opposite, minus, always plus, plus. And our factors are x plus 4 and x squared minus 4x plus 16. And good thing that I remember to pull down that GCF, easy to forget. And our final answer is 2x squared, x plus 4, x squared minus 4x plus 6. Order doesn't matter, just as long as all your factors match, because multiplication you can mix around. But you've got to have the 2x squared as one of the factors, x plus 4 should be one of your factors, x squared minus 4x plus 16. And once you've done your factoring of cubes, it might feel like, ooh, can this go further? No, it cannot go any further. So once you've done a sum of cubes or difference of cubes, you are truly done. All right. Whew. Sorry about that. Let's do it again here for number 54. Might look a little bit more complicated, but we aren't going to panic. We're just going to do the same steps as we've always done. Boringly good at factoring. Is there a greatest common factor? Something that's in all 4. And I was a little distracted there as I started doing the problem on the other page. No, there is no GCF. Okay, so the next question is critical. I'll try to give myself a little workspace here. Our second question is how many terms? How many terms are we looking at? We're looking at 1, 2, 3, 4. That question tells us exactly what to do. We aren't going to try to strategically split anything. We aren't going to look at any of the difference of squares, difference of cubes, sum of cubes formula. With 4 terms, we go straight to factor by grouping. And when we factor by grouping, we look at the first 2 terms and see what they have in common. And then we look at the second 2 terms and see what they have in common. And then we pull those things out. So I'm going to rewrite the problem: 12y cubed plus 16y squared minus 3y minus 4. Let's look at our first 2 and see what they have in common. And they have and then you're going to look at the second 2 and see what they have in common. So the first 2 have a 12y cubed and a 16y squared. Well, 4 will go into each 12 and 16. Again, we're basically looking for the GCF, the greatest common factor that these 2 have. And they both have a y squared. So we're going to pull out a 4y squared, leaving behind 3y plus 4. If we were to redistribute the 4y squared, we'd get back to 12y cubed plus 16y squared. That's how we find the 3y plus 4. Okay? Now, because it's factoring by grouping, we can expect that the 3y plus 4 is going to show up again. So how do we make that happen? Well, we look at the second 2 terms to see if they have anything in common. And 3y and 4 don't have anything in common. But, so when they don't have anything in common, you pull a 1 out. The 1 would be the GCF. And the negative in front of this first term that we're looking at is the signal, it's our reminder to pull out a negative. So we're pulling out a negative 1. And what that does is when you divide negative 3y by negative 1, you get a positive 3y. Negative 4 divided by negative 1, you get a positive 4. And so there's that match. You can expect that to show up. The 3y plus 4 should match the second time around, 3y plus 4. If you get the 3y and the 4, but the signs are wrong, it's a reminder, oh yeah, that negative, I was supposed to pull a negative GCF out. So watch for that. And then from there, you kind of zoom out, so to speak, and you can see that this big first piece and this big second piece have the 3y plus 4 in common. It's like they have their own big GCF. So we pull that out front. This is what factoring by grouping is. You pull that big GCF out front, and then what's left behind is your 4y squared, your minus, and your 1. And that's what becomes the 2 factors. Now, here is something that I want to introduce to you guys. So this is why I picked this one. I strategically pick examples in the notes so that we can cover some things that you might not notice on your own, or that you want to really get into your memory for the exams, okay? This is very similar to what you're going to see on the exam. Notice that when we did the difference, or the sum of cubes over here, I said you could guarantee you could stop. But now that we're playing the game of it's all mixed together and we have to make sure we're using the right number of the strategy to match the number of terms we have, one of the things you'll need to do is ask yourself, can this go any further? Is there anything else I can subtract? Now, there shouldn't be any more GCFs because when we pull it out the first time, that should take care of it. But just in case, you could look, is there a GCF that these 2 have in common? No. It's a nice safety net in case you missed it up here. But the other thing that you do want to go for sure, so you ask yourself if there's a GCF, but there shouldn't be if you got it the first time. But the second thing is critical. How many terms are left and can it go further? In this case, there's 2, which means that if it can go further, if it can factor further, it would be a difference of squares, difference of cubes, or a sum of cubes. It is a subtraction, so it can't be sum of cubes. And 4y squared is 2y times 2y. And 1 is 1 times 1. So these are perfect squares, so it's a difference of squares. It's not a difference of cubes. That means there's a formula for this. What's the formula? Well, if you have a squared minus b squared, the factored version is a and b, one's plus, one's minus. So we're going to split that out. So we're going to bring down our original set of factors here. 3y plus 4 doesn't go any further. But this is a difference of squares. It does go further, so it's going to split one more time into 2y and 2y, 1 and 1. 1 is going to be plus, 1 is going to be minus. And now we're finally at our finished factored form for number 54. 3y plus 4, 2y plus 1, 2y minus 1. It doesn't matter what order those show up in, just as long as those are your three sets of parentheses, your three factors. Okay, you go ahead and try number 46. Pause the video here. We'll come back in a moment and see how you did. Okay, hopefully you were able to pause and try that one, and hopefully you took also a moment to talk it through with somebody, what you just saw happening, what you need to remember from this section, any questions you might have, bring them to class or take them to your help resource, whatever is workable for you. Whatever helps you the soonest and the best. So the final version, factored form of this one is 5x squared, that was the GCF, and then 2x squared plus 4x plus 3. This one I picked in particular because when you pull out the GCF and you start looking at what's left over, this turns out to be prime. It's not factorable. So the leftovers after the GCF turned out to be prime. Now, not the whole thing is prime, it still has a factored form, okay? So even though this part is prime, you still have this as your answer, 5x squared times 2x squared plus 4x plus 3, because there is the 5x squared that we were able to pull out. So the original problem is not prime. The second part of it, inside of it, was prime, and so this is the final factored form. You can't take that trinomial any further. Okay. And if you are wanting to know how to do this problem, I'm happy to do that together with you in class. So we'll see you then, and on to page 2.